so that we can go back. Yeah. So today's topic is all about Ethereum white paper discussion. Kind of made some presentation. Let me kind of share it with you guys. There is like a lot of work that needs to be done today. Just give me a second. Okay. So first, let me take a quick poll. Like, how many of you have gone through or attempt, the Ethereum white paper, at least attempted, right? Even if you're not able to understand, that's totally fine. But like, just at least a glance of the white paper. Yeah, Aditya read through it. Okay. So Aditya, thank you. Don't worry. Great. Super. Awesome. Guys, that's what attempting itself is a very big deal. You guys have done that. Shaman actually has gone through it. Charmi did that. We got it 50%. Super, no problem at all. Yeah. Priyambi, do you have a question?
I was saying even I went through the paper.
Super awesome. Yeah, cool. Okay, then I think I have some lending hands today. I need not, from you guys. Okay, let's get started. I think in the best interest of the time, it's already 4:07. So the way how we will do is, we'll hop between the presentation and we'll actually, if you're in front of your computer, have the white paper open. Like, we can make this more of a collaborative session where we go through that. It's not that I'm going to read each and every line, etc. and all. We're not going to do that. Whenever needed, might be I'll switch on to the whiteboard to talk about different set of concepts, etc. and all, right? Okay, so to get started, so I think the whole white paper actually talks about setting the ground for and the need for the decentralization per se, right? So I always take this example of whenever we talk about a specific concept in Web3 world, we always do the parallels with the Web2 world. Okay. So Web3 did not come out of the blue. Web3 is a, sorry about this noise, I'm going to start this. Okay. So Web3 world is, an extension of the Web2 world, but like, we are talking more about decentralization, in the whole picture there, right? Now, does anyone want to give a, want to take a cut at like, what are like, two radical things, the Satoshi Nakamoto has proposed, in 2009 Bitcoin white paper? It's in the first page itself, Okay, don't worry at all. I'll go through that. So primarily, when we are talking, so no, it's not actually proof of work and consensus. Like it's yeah, kind of proof of work is one part of the whole game. So let me set the context and ground here. Okay, so Bitcoin actually came up. The whole concept of Bitcoin was around the peer-to-peer currency. Okay. So if you take the Web2 world at this point of time, let's understand the financial structure, what we have in the present world, right? So we have, the reserve banks, at the helm of the pyramid. In the case of India, it's the Reserve Bank of India. In the case of United States, it's a Federal Reserve Bank. So these banks do control, the currency circulation in the market. They do control the currency circulation, through increase and decrease of the interest rates, the repo rates, etc., and all that. And then at the lower level, at the second level, you have the banks, which is, which actually helps you maintain circulate the supply of the currency. And then at the bottom level, at the bottom of the pyramid are we, right? Retail guys, where we actually take this currency and then create a value out of it. We create a utility value out of it, by supply and demand. So we use this currency to pay for our products and services, etc., and all that stuff, right? Okay. Now, let's take a step down into how a particular transaction happens in the present world. Okay, so when I mean by the transaction that happens, for example, if you were talking about a monetary transaction, right? So, imagine now I have a bank account. Okay, let me actually take a this quick example here. Okay, so now there is a bank account of mine. Okay, and and I'm sending this. I will be using this example like multiple times. So just be cognizant of that. Just pay attention. So there are two guys. That I'm transferring. Say I'm transferring like $50. Okay, I'm transferring $50 at the same time to A and B here. Okay. So now who is actually settling those transactions in the backend for me? So when we are transferring the transactions, who is settling those transactions for us? Oh, banks, absolutely, the banks, right? So the banks do, settle the transactions. And how do the banks settle the transactions? There are certain set of mechanisms, that have been, placed, and there are certain set of rules that the banks go through. What is the simple set of, simple rule that the banks do follow? If I'm transferring $50 to A, and if I'm transferring again $50 to B, so first of all, my bank account should have at least $100 in my bank account, right? Agree? And then I should be able to transfer 50 to A, and then I should be able to transfer 50 to B. Okay. So, and there is an order of transactions. I'm not even getting into the order of transactions. I'm taking this very simple transaction here. Okay. Clear until now, guys? Any questions? Okay. So this is a simple transaction that happens in the traditional world as of today. Okay. So what we are trying to understand here is a transaction in the present world is being supported by the centralized agencies, which are the banks, who will take care of this settling these transactions, for us. Okay, clear. Now let's enter into the blockchain world. Okay. Or the decentralized world there. Okay. Now, what the Satoshi Nakamoto has done is, so I'll kind of slowly build this concept because these concepts are very important, for us to set the context. Okay. Go back and then create a new file. Sorry. So the concepts, of what Satoshi Nakamoto has spoken in his white paper are two important concepts here. Okay. So there are two radical concepts that has been proposed, by the Satoshi Nakamoto here. One is, can we create a currency, without the need of a central intermediary? Okay. So without the need of the banks, can we create a peer-to-peer currency? Okay. So that was the first, point that he raised, and he proposed some solution to that. And then that's fine. Anyone can create a currency there, right? Like we can easily create a peer-to-peer currency. Let's just give me 1 second, sorry about this. Very sincere apologies there. Yeah. So what I was trying to say is, so the concept of the decentralized currency, can we create that without any need of the central banker? In the case of Federal Reserve Bank, and which has no value and which has no backing. Okay, that's number one point. The number 2 point was, even if we were able to create a currency, right? So going back to my previous example, who is going to validate the transactions for us? Okay. So in the present world, the banks are taking care of it. There are a lot of algorithms. There are rules that have been set because the banking system has evolved over a period of decades, right? So how do we, develop the consensus? How do we agree? Which transaction came first, which transaction came second, etc., and all that. Okay. So those are the two important concepts, Satoshi Nakamoto has proposed, and this is the basis of blockchain and decentralization that was started, back in 2010. Clear? Was I able to set the context for the discussion? So what do you mean by no intrinsic value? That's a good question. So what did I say about the money that we have, right? So as of today, if you talk about a rupee or a dollar, we are creating utility value, for that particular currency, right? So how are we creating, the utility value for that? We are actually paying for the products. We are actually paying for the services. Thereby, we are increasing the utility value. So a rupee as a currency is getting value accrued because people are using it, right? Similarly, a dollar as a currency is accruing value because people are using, and there is circulation of the currency, in the market. That makes sense, Prem? Okay, cool. So that was actually the start of the Bitcoin white paper, right? So two concepts, we will base the entire discussion on these two concepts. One is how to create a decentralized currency. And the second thing is, how do you ensure, the the consensus mechanism, like how do people agree that the transactions are valid and, the order of transactions are valid. Okay. Now, moving on. So, the concept of first to file system is very important, and I'll come to that in a bit. No, actually, let me talk that now itself. So going back to my previous example, right? So now I have $100, okay, or like let's say let me have like $50 here, okay. Let me take this example, $50. So this is a very important concept, the first to file system. Okay. Now there are two people here, A and B. Now what I'm going to say is, hey, I have transferred, the $50 to A and $50 to B, at the same time. Or like I claim that, rather than, saying, I claim that, I have transferred $50 to these two people. Okay. So in the traditional system, the banks verify the transaction for me and they say, okay, hey, Kiran, you did not transfer to, B because the transaction did not go through. You did not even initiate the transaction. You are lying. But whereas the transaction, for the A did go through because you initiated the transaction. How do they tell that? There is a timestamp, there is a transaction, message that happens. And then there is a transfer of money that goes from my bank account to the A bank account, right? Now in the decentralized world, how can you say, see, if I'm coming and saying, okay, I'm transferring 5 bitcoins to 2 people here, who is going to verify that, that I have transferred 5 bitcoins, to A and B? That makes sense, guys, right? And imagine if we have another transaction that is C here, okay? And if A claims I have transferred to C, and B claims if they have transferred to C. So the whole chain, there is a linkage of the chain here. Does it make sense here? So the first to file system, actually the concept of first to file system is, what it says is the order of transactions is very important. Okay. So if I'm transferring, the money to A, and then transferring A is transferring money to C, and then C is transferring money to B, and then B is transferring money to me, right? So this is an order of transaction, right? So in the decentralized ecosystem, this order of transactions, are very important. Not only in any decentralized, but in any financial system, the order of transactions are very important. Otherwise, it will just lead to chaos. Okay. So in the centralized world, we have the mechanisms, where the order of transactions are being taken care of. In the decentralized world, we need to develop a consensus mechanism, that people should say, okay, hey, yes, Kiran has transferred to A, and then A has transferred to C, C to B, and then B again back to A, Kiran, right? So someone has to agree and give us a okay, saying that, okay, hey, this consensus, the transaction, this chain has gone through, okay? So that is this whole concept of first to file, that was, a very, very important concept, that is the bedrock of the financial system, okay? How the first to file system has been implemented in Bitcoin, we will learn in a bit, okay? So again, please keep your questions coming and please stop me at any point of time, if you're not understanding the concept, okay? Until you're clear, guys? Repeat the concept. Yeah, sure. So, okay. Let me take this quick example again one more time. Sorry, guys, and I'm just getting used to this whiteboard stuff. Okay, so let me create these transactions here. Okay. Okay. I don't want to complex or complicate, but let me do a complex thing here. Okay. Do you read anything from this? Let me draw parallels to the present, vector world. Okay. Actually, rather than doing this, let me do this quick example. Sorry, guys, a little bit. Hey guys, have any tip where I can quickly open this new whiteboards each and every time? Let me know. Okay. So let me take this quick example here. Okay. Okay. At the center is the shopkeeper for us, and there is a supplier. A, B, C, D. There is retail price here. Okay. And then there is a supplier or vendors are same. Let's do this part. Okay. So, so the first file, system actually, rather than the supplier, let me put it this way. Sorry, I'm trying to find a good, decent example for you. Let me do this quick example now. Go on. This is a good example. Okay. So imagine you guys are planning for the Goa, trip, right? And say, imagine this is you. Okay. Now you are the leader of the group, and then you, as a leader of the group, you are actually going to manage all the expenses of the trip. Make sense? Okay. Now you need to ensure, there is an order of transactions, order of financial transactions that should happen. Okay. So initially you should collect money from A, should collect money from B, should collect money from C, should collect money from D independently. And then you should be able to pay your expenses, there. Right. And then say, imagine this is a typical ideal situation. Okay. So imagine now there is a situation, say, now B is a culprit. Okay. And then say D is a culprit here. Okay. So now now A pays and then C pays you the money. Okay. When you go to the B, B says, okay, hey, I have already paid money to A, and then A will pay you instead of me paying you, the money. And then when you go to D, if D says, hey, I have already paid money to C, and I'm not going to pay you. Okay. So how do you validate, whether B has paid money to A or D has paid money to C? You're getting the concept there, right? So in the traditional world, how do you validate this particular transaction? So the typical order of the transaction has to be, everyone has to pay you independently. Okay. You need to collect the pool of the money for you to go to the trip. But these guys, B and D are culprits, and then they are lying, and they say, hey, I have already paid my money to A, and I've asked A to pay you. I have, like, similarly D is saying that. Okay. Now whom do you believe? Do you believe A or do you believe B, or do you believe C, or do you believe D? Does it make sense in the first place?
Yes, sir.
Yes, if it is getting okay, cool, awesome. So there, the concept is, the concept of first file is, you should have an order of transactions. Okay. So that order of transactions needs to be validated. So the order of transaction initially is A, B, C, D has to pay you. Okay. So that is the order of transaction. Okay. And that has to be validated by you. um, Guys, if it is getting super tough, just let me know. It is not at all tough. It is a very simple concept. Yeah.
Can you repeat the last line? What you said? Validation about?
So the initial validation is, all the four, paying you, directly, right? So that you are validating that everyone is paying you. So, but there is a gap here, So how do you ensure, these people are lying or these people are paying, you at the end of the day? So what I'm trying to say there is, let me actually kind of little bit simplify. I know there are like a lot of people who are, getting, this thing. So what I'm trying to say there is, in any financial system, the order of transactions are very, very, very important. Okay. So if I'm dealing with, okay, imagine now I'm sitting, now I'm a startup. Say I'm dealing with 3 suppliers on the other hand, and also at the same time, like, now I'm dealing with, like 5 to 10 students, for me to pay the money. Okay. Now I need to ensure, those money is coming in and those transactions are going through, right? So it makes sense.
Yes, sir, making sense.
Hi, sir. So someone mentioned double spending problem. Is the same case double spending problem as
Not at
filed
all.
to? Okay.
No, this is not at all double spending problem, guys. So
By
uh,
first to file, you mean a history of transaction we should be have the knowledge about. What is the correct history of transactions, right?
that is correct. Exactly. I'm talking about history of transactions. Correct. Yeah. It's not double spending, by the way. Okay, let's park this, we'll come to that, when I explain the other concepts, we'll come to this in a bit. Okay. So can we move on for now? Okay, cool. Okay. So yeah, we started with the concept of 2 things: peer-to-peer currency, has to be created, and then there is a proof of work, the consensus that needs to be done on top of the transactions, right? So that's what the Bitcoin concept is, all about. Now let's talk about, what this decentralized consensus protocol, this guy has proposed. So what I want you to okay, here I just want to explain this concept of, state transition system. So this is on page 5, by the way, if you're in front of white paper. Okay. So let me go back to my board one more time. So So here now the whole concept, around this, around the whole discussion, remember, will be dependent on only two main, headings for us. One is how are you going to create the transaction? Okay. The second one is how are you going to verify the transaction? Okay, makes sense. So with regards to the Bitcoin, now we will understand how to we make the transaction in the first place. Okay. So the Bitcoin white paper talks about something called as a state transition system. It is very simple. So there are, imagine, there are these three areas here. So this is a state. This is a transaction that happens, and again this is a state. Okay, it's very simple. Okay, so state is an input. Transaction is where a particular transaction happens, and then the other state is an output here. Okay, so this whole thing put together is called as the state transition system. Okay, so this is a very important keyword that you will be hearing a lot, either during this course or in the Web3 world. So state transition system ideally consists of three things. One is an input and the transaction that is happening there, and the third thing is you have an output that is shaping up here. Okay, now let me take a quick simple example of what these guys has done here, right? So for example, now this is A, and the state output system is B. Okay. Now imagine there are a couple of things that needs to happen. Okay, there are certain conditionalities that needs to be met for a state transition system. Okay, this is again simple concept here. So imagine now B wants to be again. So going back, right? So how do I think I'm confusing the guys. So now imagine now A is saying he is transferring $30 to B. Okay. $30 to B. Okay. Now, how does a typical balance sheet will look like? Pre and post. Let's do a quick thing here. Okay. So this is A and this is B. Okay. So imagine B has 100 and A has 100 and B has 0. And after the transaction, this is the transaction transfer of the $30. A should have 70 and B should have 30. It's a simple math, right? Right. Now, what the state transition system says with regards to Bitcoin is for a peer-to-peer currency to go through, there are two conditions that needs to be met. Okay. So what is the first simple condition? First simple condition is for A to transfer $30 to B. First of all, A should have those $30 in the bank account. Right? Makes sense or not? So that is the first condition that needs to be met. Okay. And the second condition, what they say is, when the transaction happens, that X dollar, that $30 has to be deducted from A, A ledger, and then the $30 has to be added to the B ledger. Okay. So these are the two conditions that needs to be happening. It's a simple math, it's a simple common sense now. Okay. But they're trying to put it in an algorithmic mode in the Bitcoin context. So what they're saying is, when this is happening, there is a peer-to-peer transaction that is happening. Any questions?
So in the algorithm, are they detecting, like, are they first changing the balance of A to 70 and then transferring 30 to B, or are they detecting first 30 from A and then sharing that detected amount to B? So how does that algorithm goes?
I think it's the later, so it's actually the later part. But any questions here, guys? On the state transition system. Because please remember this, this state transition system, we will talk in the Ethereum side also on how the state transition system, is different from Bitcoin to the Ethereum side. Okay. Now, the most important topic and point that needs to be noted here is the state transition system in Bitcoin is happening only on the currency levels. Okay. So it is happening only on the peer-to-peer currency level and not on anything else. Okay. Uh, Guys, let me take a pause here. Any questions so far? Is it like too complex, complicated, or okay, cool. Okay. So let me do one thing. Invoice this. Let me go back. So as I said, in the state transition system, there is a state, there is a transaction, and again there is a state. Okay. So the state transition function is state plus transaction should give you the output, to the new state, which is the result. Okay. As I said, the conditions: A should have sufficient DEX, A should increase, and B should increment. And the state in the Bitcoin is collection of. Okay, now let me not confuse you. I'll come to the derivative. This one here. Okay. Now you understood the basic concept of state transition system, right? Now let's apply this concept on top of Bitcoin. Okay. In terms. Sorry. Does anyone have a question? Sorry. Okay. Sorry. Okay. Now, in the state transition system, now let's apply this concept to the Bitcoin here. Okay. So again, please pay attention here. This is a really important concept and little complex, unfortunately. So what Bitcoin is saying is, in the state, this whole concept of UTXO, as a term is being written across the entire white paper. Okay. So the UTXO is technically, this is the number of the transactions that has been minted and not spent. Okay. Did you get what UTXO is? So UTXO primarily what they're saying is whatever coins that have been minted so far and not yet spent. Make sense?
Yes, it does.
Cool. So similar to what state transition system has set of rules. The state in the Bitcoin system also has certain set of rules. Okay. So please always go back to what I mentioned at the start of the session. So we are talking about two concepts here. Always we are only talking about two concepts. One is how do we transfer money in the P2P ecosystem? How do we transfer money from one person to the another person? And the second thing is how do we approve and create a consensus that those transactions are the valid transactions. We haven't spoken about consensus so far. In the Bitcoin, we are talking only about how to create the transactions at the moment. Okay. So the transaction state transition, and similar to what Bitcoin is saying is the UTXO part here. Okay, the UTXO also needs to meet certain conditions. So primarily, each UTXO, the coin has a certain denomination. Okay, and then also there is an owner that is associated with the UTXO, which is designed which has a cryptographic public key there. So the two conditions that needs to be met are the UTXO should be in that state, the left side box in the first place, and the signature of the UTXO should match that of the owner. So let me take an example here. See, if I own 5 Bitcoin, and if I mine 5 Bitcoin, okay, and then I did not actually spend that 5 Bitcoin, okay, so that 5 Bitcoin has my cryptographic public key. Okay, I'm the owner of that 5 Bitcoin there. So that is the state of the Bitcoin, the UTXO transactions that I am holding at the moment. Okay. Now, how do I transfer those 5 Bitcoins, in the Bitcoin ecosystem is what, without any decentralized authority is what the concept of the decentralized currency is all about. Make sense, guys? Okay. You have a question? Yeah, unspent transaction outputs. Yeah.
Can you just explain this unspent transaction outputs in very simple terms? Like if someone has obviously mined Bitcoin and then he's the owner, or he has someone transferred the Bitcoins, how he became the owner in relation to the UTXO.
So, as far as the white paper is concerned, so they are talking about the bitcoins that have been mined and not spent. So ideally, say imagine if you are a miner and if you mined like 10 bitcoins, and if you haven't spent those bitcoins, so those stand for the UTXO is equal to those 10 bitcoins, and you will be the owner and you have that cryptographic public key that is associated with that particular UTXO.
Okay, so UTXO is just a reference regarding mining and minting, right? Not regarding transfer of ownership of any coin. Okay.
Not at all. Not at all. Not at all. So here we were not even talking about the transferring, etc. and all. So here we are considering again two things, right? How can we create a currency without any centralized authority? Okay, that's the first thing. And then second thing is how do we transfer those currency without centralized authority and with the consensus mechanism in place? Got it, right?
Yeah.
Cool. Okay. Now let's actually come to the whole concept of the mining, where the proof of work as a consensus mechanism actually comes into picture. Okay. So if you go to the page number 6, you will see a certain blocks there. And let me go back to my sort of a drawing code here, sort of explain.
Sir, if you don't click on new whiteboard, but you can scroll also the whiteboard, or maybe erase everything together, maybe.
Yeah, I know. Sorry about that. Okay, so far what we did, we kind of created the, we understood how the P2P currency can be created, right? How the transaction happens. That's number one. Sorry, sorry. Right? Sorry, guys. So the second thing is now the consensus mechanism. Okay. So actually, let me draw this diagram. Yeah. So you're saying I can scroll this down? Oh, okay. How do you scroll this down?
Kiran, try zooming out. Yeah.
So I want to explain this diagram. So, there are two concepts here. One is, so this is a state transition function, right? This is a state. This is a transaction, and this is a state here. Okay. Now, in the concept of mining, what is happening is, so there needs to be nodes. There are these blockchain nodes that needs to be. They need to write these blocks on the blockchain each and every time. So this is a block here. Okay. So there are like multiple blocks that will be written here. Okay. So I'm slowly trying to build and connect the dots here. Okay. Now each block will have a transaction here. Okay, guys, just understand this carefully. Kind of visualize this. Now, in the first step, what we did was, we created a transaction. Okay, so there is an input, there is a transaction, there is an output. Okay. Now, the second thing, what we are trying to say there needs to be a consensus mechanism. People need to agree that the order of transactions are correct, and they need to verify whether the transactions are correct or not. Okay. For that purpose, so that is where the whole mining, concept comes into picture. This is the proof of work, as a mechanism that Bitcoin has developed. Okay. So what happens in the Bitcoin world is, there are different set of nodes, and these nodes have to write blocks each and every 10 minutes onto the blockchain ecosystem. Okay. And each block is a set of transactions that are being recorded on each each and every time. Okay. So for example, in this first case, I have like 3 transactions that I have done. Okay. And all the three transactions has to be written on this particular block by the blockchain node. Okay. Now, say imagine now I'm doing another transaction, say 4, 5, 6 here. Okay, which is coming say after 2 hours. So after 2 hours, so imagine now this is block 1 here. Okay. And we are talking about blocks getting created 10 minutes. So you can do the math. I'm saying like, say block 20. See, this block 20 will have these transactions of 4, 5, and 6. Okay. And say in the first case, if the transaction 4 is referencing to transaction 1, the 5 is referencing to transaction 2, and 6 is referencing to transaction 3 here. So I will also similarly have the connection between the block 20 and block 1. I hope I'm not confusing this. So what I'm trying to say there here is, each and every time the transactions are done on blockchain, so those transactions are written on the blocks, which are created by the nodes, and there is a linear relationship between those transactions. Or let me take a quick example, going back to my the A, B, C, D, and the Goa trip, right? So imagine, what did I say? A is paying and D is paying. A is paying and C is paying, and B is lying and D is lying. Okay. Now imagine if B have already paid to the A, so that transaction will be recorded in some blockchain here, in the blockchain world. So if this transaction is not found on the blockchain, you can say that B is lying and B hasn't paid this transaction to A. Okay, that money to A. Similarly, D to C, that is a live transaction there. That makes sense.
Yes, sir.
Um, so what we are trying to do here is, let me kind of simplify. I forgot about this, complete diagram. So each and every time a transaction is created on, Bitcoin on a blockchain, so those transactions are written onto the blocks by the nodes, which are managed by the miners. Okay. So for writing those transactions onto the blockchain, by the miners, the miners are incentivized. The miners are incentivized, through Bitcoin. So that is how they mint Bitcoins there. Okay. So as and when miners write those transactions onto the blocks, whatever transactions are happening are recorded in a sequential manner on the chain. Okay, and you are creating a consensus mechanism. You are creating a mechanism where you can actually go back and verify whether those transactions are authentic or not. If someone claims, I have transferred 10 Bitcoin to, X claims, I have transferred 10 Bitcoin to Y, you can go back and verify whether they have, really transferred it or not by going to a particular block there. Okay. So going back to my first thing of, creating a payment mechanism, the peer-to-peer currency, and then, creating a consensus mechanism around validating those transactions, right? So those validating those transactions are happening on Bitcoin blockchain with the help of nodes and blocks. It's as simple as that. Any questions here? Let me take
How
a
does
pause. Let me-
how does one go to a block to check a certain transaction and for its validation? Since block might be very early and very behind, suppose an year ago, something like I don't know.
Yeah, that's actually a very good question. So imagine, so if you're referencing to some particular transaction in 2015, and you are doing the transaction in 2020, your question is, how do you verify the authenticity, whether the transaction is valid or not, right? How do you get access to the 2015? That's an interesting question. Unfortunately, I need to check that out as well. So. Uh, Any other questions? But like on a higher level, did you get the concept of like, peer-to-peer, currency, and at the same time, how the consensus mechanism works in, blockchain world? Not blockchain, especially in the case of the Bitcoin world. So let me switch gears to, my presentation here. So as I said, peer-to-peer transaction is referring to the state transition, and then the state transition needs to be compared with the consensus mechanism, in the decentralized manner. That is where the nodes comes into picture. On the top of it, blocks comes into picture. So the nodes need to write blocks each and every time, every 10 minutes, is according to the white paper. I need to double check on, how many blocks are being written there. Okay. As one interesting thing here is, as you keep writing the blocks each and every time, the difficulty of the block increases, and then it becomes very difficult for anyone to, erase the previous data, etc. and all. Okay? You can check that out, the characteristics of what this block is all about. Again, similar to how the state transition system has a certain set of tools, you can verify whether that particular block is verified, valid or not, by following certain set of criteria here. Okay, so I'll share this. You can read and check that out there. Okay. So I think let me focus a little bit of time here on, the limitations of Bitcoin, and since we're talking about Ethereum, we'll talk about like what this whole concept of Ethereum has, why Ethereum has come into picture when there is a Bitcoin blockchain. So when people talk about Bitcoin blockchain and they're building applications on Bitcoin blockchain, there are like a lot of limitations, unfortunately, on the Bitcoin as a blockchain ecosystem. So primarily, the first thing is, as I mentioned, Bitcoin is primarily used only for the peer-to-peer currency, only in the financial world. Okay, and also Bitcoin is actually kind of a linear thing, right? 1 to 2 and 2 to 3 and 3 to 4. Okay, so it doesn't provide wide gamut of stuff for for anyone to experiment and build applications on top of the Bitcoin blockchain ecosystem. Okay, so that is kind of the number one limitation of the Bitcoin. Okay.
What do you
Uh,
mean by linear? You said right now.
Sure. So linear, when I meant, each transaction, so the blocks are being referenced. Okay, let me take this quick example here. Okay. So now, we are doing this. Okay, the blocks are being referred as 1 to 2 and 2 to 3 and 3 to 4, right? So there is 2 is relying on the information of 1 and 3 is relying on information of 2, 4 is relying on information of 3. Okay, so when you have to retrieve the information of one specific UTXO or one specific transaction, you can easily retrieve the information. So for example, say I am transferring money to you and you are transferring money to someone else and someone else is transferring money to someone else. Okay, so we can actually track that linear transaction that has happened, 1 to 2, 2 to 3 and 3 to 4. Okay, but the number one limitation in the Bitcoin world is, say if you have to track 2 to 3 transactions at the same time. Again, thinking of an example here. Okay, let me take this example of this derivative contract might be. So in the case of the derivative contract, right, say if A and B are transferring the Bitcoin, okay, and there is a derivative contract, that means the price of the value goes up after a certain period of time. Okay, now how much money each one of them should get is a very difficult thing to track in the Bitcoin blockchain world. We get it? Sumit?
Yes, but everyone would be assigned some percentage value, right? So how would it be difficult in that case of in that example you are trying to explain? Even if after
So
it's done.
So imagine, how should I, let me take this, might be an example of, the swaps, have you ever used, like, learned, looked into the D by DX or this other exchanges,
Yes.
the swaps that
Yes.
happens, right? Okay, simple, cool. Now, in the Bitcoin world, what is happening is there is only one-to-one transaction that is happening there, right? So again, I think I'm not able to. It is there, but I'm not able to get it to you on the paper. Let me try this. Okay, hold on. So, when I mean by linear, okay. So what I meant by linear is, so 1, 2, 3, 4, 5. Okay, this is a very simple transaction that is happening, in the Bitcoin blockchain world. Okay. So there is a bigger limitation that, okay, so imagine now we are talking about, say, ETH by USD, okay? And then say BNB by USD, and then say there is BTC by USD. Okay, so each of these independent transactions can happen, at the same time. Sorry, each of these independent transactions can happen on Bitcoin blockchain. Okay, I'm trying to simplify this. Until then, clear?
Yes.
Okay. Now imagine if you're trying to do
So you are taking USD. It should be BNB by BTC, right? CTH by BTC, all that.
I'm just taking a hypothetical example, don't go
Got
by terminology there. Okay. So, but whereas say if you want to do ETH by USD and then BNB by USD at the same time, okay. When I mean by linear, so imagine if you want to process these two transactions at the same time, okay, on Bitcoin blockchain, there is a limitation here. This can't happen. When I said at the same time, did you get that?
Okay. So a single blockchain, the Bitcoin blockchain, can't process two in and out transactions from itself at same time. That's what you're trying to say. Okay. It has to
Yes.
proceed linearly one after another. That's what you are trying to say. Okay.
That's exactly correct. Yes. There
Not
are
parallel. The parallelism is not implemented in Bitcoin.
parallelism, and at the same time, multiple transactions are not even implemented in the Bitcoin blockchain.
Understood.
And also,
So does linearity give its Bitcoin some benefit over Ethereum, or it's just
so it gives a benefit only in the financial terms, right? So if you are doing a simple proper transaction, say imagine if you want to run only a proper bank, I think Bitcoin blockchain might be the best fit, okay? Because it is very easy to go through those transactions and then kind of track it and trace it. Okay, again, it's a very simple transaction if you're talking about. But if you're trying to build multiple applications on top of it, very complex applications on top of the Bitcoin blockchain, the Bitcoin blockchain doesn't support those, because of the limitations that I have mentioned before.
Understood. This makes it not scalable. That's what you're trying to say.
That's exactly correct. Yeah, not scalable. Okay. Going back, and one more interesting limitation of the Bitcoin is, as I said, it's a linear thing. 1 to 2 and 2 to 3 and 3 to 4. Unfortunately, the Bitcoin blockchain doesn't support the looping system. Okay. So when I mean by the looping system, right? So if most of your developers here, so you understand this if-else concept, right? So in the if-else concept, what happens? So there is a code that actually runs through multiple times until you hit a result, until you get a output at the end of the day, right? So the Bitcoin blockchain doesn't support the looping system. Okay, so which is one of the bigger limitations, because if you want to bring in multiple permutations and combinations of a particular application, if for you to build an application in the Bitcoin blockchain doesn't support that code. Okay, so that is the number one limitation of the Bitcoin. So I'm sure most of you heard of this concept of Turing complete language. So Bitcoin is not a Turing complete language. Okay. So the Turing completion, what Turing completion means is adhering to specific, code and specific logic. A programming language should not hinder your ability to create any sort of applications or any sort of logic. Okay. So the C and Javas and Pythons, they are all Turing complete languages. Okay. So there is no limitation, for you to write the code or to build a certain set of products there. Okay. But whereas in the Bitcoin blockchain, because of all these limitations, you cannot write the loop statements there. And you cannot actually bring like multiple transactions at the same time and all that stuff. So these are like multiple limitations that Bitcoin blockchain has, and that is why Vitalik has written this whole paper about Ethereum in 2014. Okay, so that is where the Ethereum as a blockchain comes into picture. Okay. I know we spoke a lot about Bitcoin for about 1 hour. Let me take a small pause here. Any questions so far? Yeah, I'll try to use Miro. Thank you. Yeah, Deepak, go ahead.
Yeah, so I have a question. How do you see the future of Bitcoin with the rise of quantum computers?
Sorry, I did not. Can you speak a little louder? Sorry.
Okay, so can you hear me now? Yeah, okay. So I was asking, how do you see the future of Bitcoin with the rise of quantum computers?
See, again, totally different topic, from what we're discussing. But from the Bitcoin perspective, right? What is the major incentive for the miners as of today? If they keep writing those transactions, or if they keep creating blocks, and if they keep writing those transactions on those blocks, they are being um, incentivized with the Bitcoin, right? At one point of time, people were given in 2014 when Vitalik wrote, he was talking about miners getting 25, Bitcoin for putting some transactions for creating one particular block. Okay, so I now as of already 19 million Bitcoin in circulation. So the total amount of Bitcoin that is out there is 21 billion. And of course, we know that the last Bitcoin is going to be minted in 2040. And the Bitcoin, is halving every 4 years. To answer your question again, I need to go back and check. But like my hunch is, even though the concept of quantum computers comes into picture, uh, the the mining, benefits vis-a-vis the cost, and the return on investment is kind of slowly coming down, from the Bitcoin perspective. Okay, so there are only 2 million Bitcoins left. Obviously, someone is have already spent, like, so much of money on mining equipment and all. I don't have to get too deep into that, but at this point of time, from the mining perspective, even though the quantum comes into the picture, there is very limited ROI left for you, unless, like, someone wants say 1 million Bitcoins out of the 2 million. Okay, it's also a matter of time, right? It's not that it is going to happen in next 10 or 20 years. So we're talking about 100, 120 years, unfortunately. Does it make sense? Did you answer that question, or at least?
Yes, it makes sense. Thank you for the answer. I have
I think
one
Sumit
more.
has put some stuff here. Yeah, create a new blockchain, short time span, spoof the chain for wrong transaction. Yeah, I'm talking from the mining perspective. Yeah, of course. With the supercomputer, you can create, like, chains very easily there. Yeah, go ahead, Deepak.
Yeah, so I had one more question here. Maybe I think you have answered it to a certain extent already. But question basically is like, if let's say all Bitcoin is minted out already, how are people who run node for blockchain, for the Bitcoin blockchain, how are they gonna be incentivized? What is gonna keep them from keeping up the network in the air?
Actually, that's a good question, and someone also posed that, what is going to happen to the security of the Bitcoin blockchain ecosystem. Again, like, anyone wants to take a cut, to be frank, again, I need to check on that. I'm still trying to understand what is going to happen with the security. But that's a good question. Yeah, that's a question that is coming up very often.
Can you write this question down, Deepak, once in the chat? I lost that one.
So primarily, what he is asking was, so if what is the incentive for the miners to keep the blockchain secure? The costs are going up, and they're not being incentivized with the new BTC. let's do one thing. We will let people to answer on the chat, and let's continue with the Ethereum. We'll take that in a bit.
Kiran,
So
can you do
Yeah,
one
I
thing
think
when someone asks some Q&A and if that's unanswered, can you paste that or collate that so that can be recorded in our August cohort channel,
we'll do that. Yes,
right?
we'll do that.
yeah. Hey guys, this is Nirmal here. I think I can take a shot. So there's this
Sure.
concept called hashing, which is done. So say for example, right, like I mean, in this case, right, whenever a block is created, there is a hash that is created along with the entire block, and all these hashes are linked to one another as part of the chain. So let's say provided one miner, right, like if they choose to make changes of the transaction inside the block, the hash of this already created block actually changes, which will lead to subsequent change in the other blocks. So eventually what happens is like, say for example, you have like 50 blocks right now on blockchain, and there is 51 block, there is block number 52 that is getting formed. This hash is what binds every block to each other. So as a miner, if the new block which is created, say block 51, I do a foul play and try to change the data inside, and then there will be other miners also, like who will be mining it. So the point is, uh, whenever say this block 51 is created, a hash is created, and this hash becomes an input to block 52, and again block 52 will have its own set of transactions, and then again another hash is created, and the hash value of block 52 is given as an input to block 53. So how this hash is created? It is basically an alphanumerical code. It is automatically generated, and it is linked to the previous hash plus the set of transaction which is inside. So if anyone in the network tries to meddle with or try to make changes in a block, the entire hash value changes. When the hash value changes, it breaks off from the chain. So whenever a transaction breaks off from the chain, the network will find that, hey, this is a suspicious transaction, and knock it out. Yeah, I don't know if that answers your question, but yeah, I can try to explain it. I mean, after the session on Discord as well.
Yeah, sure. Thanks, Nirmal. That's a great explanation. Deepak, let's start with Nirmal. To get more um, insight into this. Okay, cool. So continuing our discussion on Ethereum, right? So as I said, because of the limitations of whatever is there on the Bitcoin blockchain per se, so the new blockchain has emerged, which is the Ethereum blockchain. And the main characteristics, obviously, it's a Turing complete. Interestingly, you can write loops, within the Ethereum. Of course, in Solidity, you will learn that. Any sort of consensus-based applications, can be developed. So primarily, what they're saying is, the whole consensus mechanisms. So you can actually write, the smart contracts and build any sort of decentralized applications on top of Ethereum. So that's the whole concept of the Ethereum blockchain is. So there are 2 to 3 concepts that I wanted to touch, and then we wrap this, which is the most important part. So one, going back to my state transition example of Bitcoin blockchain ecosystem. So if we see page 15 of the white paper, there is a Ethereum state transition function. Okay, so I wanted to kind of draw parallels between the state transition function of Bitcoin and Ethereum. I would like to talk about this a little bit, and then I'll go back. So primarily, what the Ethereum as a blockchain has developed is, they have developed an easier way, for people to interact and send information within the Ethereum blockchain. So they're talking about 2 accounts. One is an externally owned account. Priyanshu actually covered in the second video. So those videos have been uploaded. I'll come to that in a bit. And also there are contracts. So Ethereum primarily has two concepts. One is an externally owned account and a contract there. So let me actually explain here. Let me go to page 15. I think this would be a good example here. So if you talk to, if you see this one here, guys, by the way. Sorry about that. Okay, so primarily what they're saying is, so Bitcoin has a state, there is a transaction, there is a state, which is a state transition function. In the case of Ethereum, in the state, and in the case of the state of the Bitcoin, what is happening is you will be able to transfer the currency there, right? That's what we discussed about. It's all about the currency that can move from one state to the another state, with the transactions in between. Whereas in the case of Ethereum, the interesting part is within the state, you can have those messages and transactions. Okay. So, and what they're saying is, the transaction, the state transition system of an Ethereum consists of one message moving from one state to another state. Okay. So how do you define, that message to be moved from one state to the another state is through, different set of codes there. Okay. And if the other state, the output state, is a contract, for example, in the case of the Ethereum, that other state can actually give the response back to the initial state here. Okay. Just try to understand the subtle difference here. In the Bitcoin, if you're sending money $30, from A to B here, that's it. That's pretty much done, right? So if it is B to A, you cannot actually, you can do that, but like B to A will be recorded as separate transaction, separate block, etc. and all. So that's why I meant of the linear thing, so there is no sort of a loop there. But whereas in the case of Ethereum, what they're saying is there are messages here in the input side, and the messages can be transferred from the input to the output, to the transaction, to the contract, smart contract code, that design that you mentioned, the logic that you have mentioned. And on the other side, when there is an output, which is a smart contract, they can actually receive your message and they can actually reciprocate to your message. Okay. So that reciprocation of that message is happening through what is called as function. Okay. So you will learn, like, mostly the concepts of function, like various functions, in the solidity part. So what primarily Ethereum has done is, they have taken this concept of Bitcoin blockchain, instead of, the currency, part, they kind of improvised, that blockchain a lot more and added these messages and the transactions, smart contracts, the ability to communicate with each other through the code and functions, and the smart contracts there. Okay. So primarily they have developed a different set of programming language, which is in this case, there are multiple languages that Ethereum uses. Serpent is the high level language that they have used initially. Now, of course, everyone is coding on Solidity. So they developed the programming language to create that loops and interaction between the different set of blockchains. So primarily the block interaction is coming in the Ethereum blockchain per se. So that's what I wanted to tell. Any questions?
Yes, Kiran, I missed you on that part where if I understand how Ethereum message can be created by external entity or contract, but how is Bitcoin created only externally from the past till now we have talked about?
Yeah. So oh yeah. Okay. This one. So Bitcoin. Okay. So in the case of the Bitcoin, right? Okay. So what the paper was talking about is so for the unspent transactions are the ones which are used to create the peer-to-peer currency in the Bitcoin. Okay. So those transactions need to be mined, so they're actually created, on the blockchain, but like there is no transaction that is happening on the blockchain before those transactions are coming onto the chain. Does it make sense? So they're being created, outside of the system, and they're being brought into the ecosystem for the transfer and for spending, and for recording those blocks, for recording those transactions on the blocks, etc. and all. But whereas in the Ethereum, what they're saying is, so I as an external account can send information to the contract which is sitting on Ethereum contract, and also the contract can talk to different contract. The contract is the internal part of the Ethereum, so we are trying to bring in the external part and the contract part, and the integration and the talkability, factor between, those two aspects as well. So that's what Ethereum is all about. Okay, guys, any other questions? So with regards to transactions, I'll let you guys read through, page number 15. So I think this is a very important part, how the transaction looks like, in the Ethereum world. So the transaction consists of these multiple steps here. Okay, so this is important to understand because this is the basis for the coding and the solidity as well. So there is a recipient of the message, whom you are actually sending the message to. There is a signature of the sender, so I'm sending message to someone, like, my signature is there. And then there are two concepts of start gas and gas price. Okay, so what is the gas price to do that in a particular block there, and then there is a start gas there. You will understand when you run a particular smart contract on this. As I said, look into state transition page 5, read through that multiple times. That is very, very important to set the context for you in the coming days. So I did not go in depth about the externally owned contact and other concepts there. We'll talk about those in the coming days. Once we go through the videos, we'll build that along with the videos there. Any questions?
Hey, Kiran, can you share this document on the Discord channel?
Yeah, I'll do that. Guys, any questions? Okay. Either you understood this, or I confused you a lot, or either this is totally gray. I don't know what it is. At least put something in the chat. Okay. Guys, what is happening? Hello? Guys, any questions? Feel free to unmute and ask. So there are those 3-4 concepts that you need to understand. How to create transactions, how do the transactions get verified, the limitations of blockchain, and why Ethereum has come into picture, and what are the benefits of Ethereum, right? Turing complete, you can do loops, contracts talk to each other. There is externally owned contact, there is, it was covered in the second video, which was put on the Discord link. We did not talk about how the code gets executed, and what are the fields that go into the transaction in the particular Ethereum. And as I said, we'll cover that tomorrow or day after. Once you go through those videos, to kind of help you understand those concepts there. So, Matti, it is also good to talk about a little bit on the applications. So I'm sure you might have touched upon, read through this white paper, right? So there are multiple applications that have been built on, that have been mentioned about being built on Ethereum in the white paper, and most of the applications now are unicorns, billion-dollar companies, billion-dollar valuations, etc. And all. Gideon, we put in the white paper on the Discord. I'll share that again. So one of the things, if you're looking building long-term career in the Web3 world, again is start following, if you want to be in the Ethereum ecosystem, primarily kind of start following these Vitalik's blogs that he keeps writing once in a while, because that is where these new concepts have been introduced. If you talk about the applications here, the financial derivatives, there is a D by DX, that has become very popular. Swapping, we talked about that, like, we had Uniswap that came into picture. Stable currencies, again, the whole saga of stable currencies and how many stable currencies have come into picture. Decentralized file storage, you spoke about that, and then IPFS came into picture, and there are like multiple solutions that are being even developed in the decentralized file storage. He spoke at length about DAO as an ecosystem. So again, DAO as an ecosystem, you're seeing so much of progress, so many models that are being shaped out there. So again, like multi-signature, Gnosis is one of the players in the multi-signature ecosystem. So what I'm trying to say, gambling again, like there are so many startups that came in the gambling space. Cloud computing, I haven't seen anything. If you have seen anything, let me know. Decentralized marketplaces, again, like NFT marketplaces and all, so many have come into picture. So this white paper itself, the applications that he spoke about, each and every concept is a, as I said, multi-billion-dollar company. You can keep track of what he's talking about. He's talking about like a lot of L2 solutions of late. He's talking about ZK EVMs, talking about soulbound tokens and applications of soulbound tokens, etc. And all. Need not be that every concept is a every idea is a great idea and will be has humongous potential, but at least good to have a glance and understand if your area of interest fits there. There is nothing wrong with experimenting and start building it. Okay, so I would always say like start looking and reading the the blogs and anything in the Ethereum ecosystem which is being released with Ethereum foundations in the developer groups there. Any questions, guys?
Kiran, what's the ETA of this call? Well, ending ETA. When this will be concluded?
2 minutes.
Okay. Got that.
That's why I was not able to cover different concepts. I don't want to overburden because this is little complex. So what we'll do might be, if you did not understand anything today, might be don't worry. Might be we'll take this whole white paper in smaller chunks. If you want us to do it, or like we can group with people and then can start doing that as well. To kind of demystify this. It took me a lot of time as well. So,
Kiran, for me, I had gone through that white paper, Ethereum white paper, up till the how it makes you understand about the Bitcoin and what are the limitations of Bitcoin. But I had asked you a question in the Discord, if I remember, about some line. So what the
I mentioned about that, right? So combine that with the derivatives. So what he's trying to say there is this blindness concept. He was talking about, right? So scripting, the loops cannot be created, and also the best example is the derivatives contract. So okay, let me take this quick example and then we'll wrap up, right? So primarily, ideally, what happens in derivatives? Why do you buy derivatives? So you anticipate. You don't put in that entire money. You put in a fraction of that, and then you anticipate that contract will increase in value or decrease in value. It's as simple as that, right? So the best example that he has taken is around the derivatives contract. So for example, you and me have purchased like 100 BTC today. Okay. See, imagine I am betting that the BTC price will go down, and you are betting the BTC price will go up. Okay. So the two orders are already punched in the system. Now, 30 days down the lane, okay. How do you kind of distribute the money between both of us? Okay, what is that important decision-making factor in how do you compare or how do you decide like, how much money should go to you and how much money should go to me? Simple. There should be a comparison mechanism, right? So what is the price? Imagine like we purchased, the BTC in the USD, right? So what is the price of the BTC at that point of time, in comparison to the USD? Okay. So you kind of liquidate those contracts at that point of time, and then like you whatever money you should get, depending on how the contract performed, how the asset has performed, whether it is an increase or decrease in the value, and I should be able to get, some money. Okay. So this whole concept, the comparison, it has to come from a data feed, right? So it's a USD by the BTC. What is the exact price that is there, at the end of 30 days, has to come from the data feed. This whole concept is the Oracle concept, which is where Chainlink, is a prominent leader in the Oracle concept, where it actually provides the data feeds. It's not only for the derivatives. So, for example, if you want to understand and predict, do a gambling blockchain startup, okay? So say imagine the gambling blockchain startup talks about weather predictions. Okay. So you will be able to write a smart contract. Okay. You will be able to say, okay, hey, XYZ will get the coins. XYZ will get the rewards based on, if your prediction, is correct or wrong. Okay. This is all fine. This is all you're doing on blockchain. But on the top of it, the data feed has to come from an external party, third party system, right? So that external third-party system is what this Oracle is all about. This connector between these two, systems there. The blockchain cannot host the weather data. It's a totally external data there. So what he was talking about that is, in the Bitcoin as a blockchain ecosystem, you cannot integrate. There is no possibility of integrating that external systems, this Oracle and the data feeds, into the blockchain. And he's saying like you cannot make predictions. If you're making those derivative contracts, like the prediction about like how much you should get and I should get cannot be made. Okay, that is a number one limitation. Not number one limitation. That is one of the limitation. Is what he was talking about. So he's talking about the lack of loops. Turing incompleteness, the inability to connect with the external third-party systems, the inability to do the parallel transactions. So these are all the limitations of the Bitcoin blockchain ecosystem. Okay, so if people are talking about, okay, hey, you can build on a Bitcoin blockchain ecosystem, now you can go and debate why you cannot do that. Okay, if they say that I'm building an NFT marketplace in Bitcoin blockchain, it's absolutely BS, So like you can go and debate that, okay, hey, these are the limitations, how are you building it? It doesn't make any sense. So he was picking up those limitations and he's saying Bitcoin is good, it gave us the background for us, so far, it gave us, the blocks and blockchain and how that whole ecosystem works, the consensus mechanism, the proof of work mechanism, everything is great, thanks to Bitcoin. Now I'm taking the Bitcoin blockchain and then I'm adding, more features on top of it, building this programming language for anyone to build any application, and we are trying to make this more robust. Okay, so that is this whole concept. The Vitalik has come back in 2014. I was actually going through a very interesting, YouTube video that he spoke about this Ethereum thing in 2015 at a DevCon conference, and I'll share that with you on the Discord. Please go through that. You'll get more understanding about this is along with like what he wrote in the white paper, but he gave certain reasonings about the externally owned account and like why he has to develop the Ethereum as a blockchain ecosystem or not. Yeah, I think I gave you a very long answer,
Yes.
but hope
I
it
understood
makes-
it, the problem, the fault of value blindness. I understood that. Okay, and one more question, just last. You said there are
Sure.
many languages we can work with on EVM, right? Like Solidity. What are the others?
On the Ethereum
Create.
thing.
Yeah,
So
for
Ethereum
Ethereum.
actually uses this, when they wrote the white paper, they used this Serpent, which is a high level language. And I think they also use Viper, as another programming language. But I think those programming languages have some sort of limitations, again, they are like very high powered languages. The reason why people are sticking to develop, Solidity is because of the developer community, right? So if you have a question, like, you can go check if that, error has been occurred on the ecosystem before, and if it has, like, you will find an answer on the internet. So it's just that the developer ecosystem is so robust, and also Solidity is easy to learn, to be frank. I'm telling you, like, if you guys put in the effort, you'll be an expert in pros the next 4 weeks for sure. I can vouch for that. But you just need to put in that effort. So it is similar to whatever programming languages that you know. That's why, like, people say JavaScript. You need to know JavaScript because the syntax and the the code is similar to, like, how JavaScript looks like, etc. and all. So yeah, don't get into that. And I think Solidity is good enough.
Yeah, got that. Thank you.
Guys, one last question and we'll wrap up. Yeah. Okay, I forgot to tell you. The most important part, I'll release the calendar for the rest of the week. Give me some time by end of the day. So 3 videos have been uploaded on our website, web3learn.io. I shared the link to the videos both on the Discord and on the WhatsApp group. Please go through those videos. There are like 3 videos which talks about basics of Solidity, talking about what is externally owned account, and you will be able to write a smart contract in the third video. And there is an assignment hidden in one of those videos as well. We would like you to watch those videos and then complete that assignment for this week. Now, next ideal steps are super awesome. Here's the second video. So the next steps are, like, from starting from tomorrow, we will have a daily Discord session at 8 o'clock. Where it is going to be an AMA session. We will try to talk about certain topics for about like 10, 15, 20 minutes, from the theory perspective. Most probably we'll talk about EOA tomorrow, what is externally owned account. So watch that second video for you to get an idea before coming to the discussion. And also you can ask any questions and we'll attempt to answer those. And Wednesday, 8 o'clock is the doubt clearing session, which will be there for about like 90 minutes to 120 minutes. So it's like close to 1.5 to 2 hours, where you can ask any tech related questions. If you're getting stuck, getting any errors. Again, like, if you're getting any errors, don't wait until Wednesday. Like, put it in the Discord channel, and then we'll attempt to answer that as quickly as possible as well. Okay. So that's kind of the ideal next steps, for us. Yeah, look forward to seeing you. How are we going to submit the assignment? Yeah, this is a good question. So just wait until might be Tuesday. I'm trying to put, have a session for you guys on GitHub on how to create GitHub, create the repos and push the info onto the GitHub. Attempt the assignment, but like wait until Tuesday where you can actually push the your assignment, that repo onto the GitHub. Okay, so the assignments are submitted only via GitHub. Okay, so there is no other way that we do encourage. The reason is, at the end of the day, it will actually serve as a proof of work for you when you want to start applying for intern positions or part-time positions or even full-time jobs. Okay, so GitHub is more important. If you don't know how to create and how to push repositories, don't sweat. We will do a session on Tuesday, most probably. You'll be able to get an understanding about how to do that. And all the assignments will be submitted via GitHub. Any questions? Okay. If not, like, thanks once again, and like, have a great Sunday, guys. See you guys tomorrow. And yeah, if you have any questions, please put that in the Discord and the WhatsApp channel. Yeah. Good. Thank you so much. Take care. Cheers. Bye.